Hello? Okay. So, authentication. So what is authentication? We need security is a very important concern in any type of application, right? So authentication answers the question who is requesting access to a particular resource. And basically authentication let you to reach some application. If you are not authenticated, you are not going to reach to an application, right? And there's identity. Identity is a singular persona used by an actor to identify itself, right? After authentication, or with the authentication, I'm identifying that this is me and using some sorts of credential, right? So when we are entering username, password, and that is the credential, and with that username, password, I am identifying that this is my account, and I'm authenticating myself. Now, there are two different types of communication that happens, right, in microservices world. One is user to service communication. Another one is service to service communication, right? So microservice world, we have lots of different services, right? And they're communicating with each other. There can be, synchronous communication. There can be asynchronous communication. And for all those communications, synchronous, asynchronous, event-driven communication, everything, we need some sorts of authentication. So there are different types of authentication, if you see. Basic authentication, API access token, OAuth 2, bearer tokens, and MTLS. So MTLS is a mutual TLS, right? And mutual TLS being used only for service-to-service authentication. And MTLS kind of is being used by all the service meshes. When inside a service mesh, most of those applications, they communicate with each other. They use MTLS for authenticating each other. So if we are running our workload in a Kubernetes cluster, we should have some sorts of authentication between those services. If we are not providing a service mesh, then that's authentication can be through a OAuth bearer tokens. But if you are using service mesh, that can be done through that MTLS. Now, for user to service authentication, so there's basic authentication, API access token, or OAuth 2, bearer tokens, all those things are there, right? Now, which one should we use? So there's a concept of identity provider. An identity provider is a system that provides, creates, stores, or manages digital identities for certain users, right? So IDP is generally used in modern days, right? So IDP can be external or it can be hosted internal as well. Like Keycloak can be IDP, or Okta is a very popular IDP nowadays. There's PingFed, then there are other IDP services as well. Right? Every cloud has their own IDP services. So what IDP does, IDP directly authenticates users, provide authenticated service to third-party service providers. Also, it provides a single set of login credentials for an end user, right? And if we see here, identity providers supports SAML, OIDC, and OAuth 2. So OIDC, let's talk about OIDC. We all know SAML, right? It's a markup language. Through that markup language, we provide kind of some sorts of identity provider configurations, right? And OIDC, let's talk about OIDC. OIDC is a very popular concept nowadays, right? It's called Open ID Connect. That's what OIDC is. So through OIDC, suppose you are using AWS, right, for your cloud provider. Now, if you are trying to authenticate with AWS through IAM role, right? Now, to even reach out to AWS, you have to provide AWS access key and secret key, right? So you all know. I think Any cloud provider, if you want to use their APIs, you need that access key or secret key, right? But instead of access key and secret key, you can use OIDC. So OIDC provides you a way to authenticate the application itself with the cloud provider. So there is a OIDC server runs in every cloud, and through that OIDC server, when our application talks to OIDC cloud or OIDC server inside the cloud, then it provides an access token, and then through the access token you can log in, right? Or you can use the APIs. Now, so for services to reach out to any other services in cloud or components in cloud, the recommended way is to use OIDC. Now, the JOT token, JOT is the new standard which is used as a security token. So all the tokens that we get from IDP, the recommended way to get it as a JOT token or JWT token, right? And that JOT token, when you decode that token, and you can see there are a lot of informations in that JOT token. So you can pass a lot of different other informations, but JOT token has a limitations, how many informations you can pass it into a JOT token. So you have to kind of figure it out, like how many informations you want to pass. So suppose this is a typical, this is a typical architecture that you see. So when we call it like front end, so that means the UI, right? And there can be non-web front end, which is the non-web UI. And then there's an experience service, there's a capability service as well, right? So the capability service means the backend service. The experience service means like the service that calls the capability service, or kind of like a BFF or backend for front end, if you think about it, right? So if you see here, there's an auth server which talks to the external identity provider. And any login that happens from front end, it talks to that external identity provider as well, or non-web front end as well, right? So all the other service behind that front end, they don't talk to external identity provider. So how do they authenticate? How do they know that their requests are authenticated when they pass that request to the backend servers? So basically, they verify the JOT token being passed to the backend services, and the backend services verify that JOT token, saying that I need to check if this is a valid JOT token or not, right? So you can do that through JWKS or JOT key set, basically, right? So every IDP provider provides you a key set, and using that key set, you can cache that key set as well, and you can check if the JOT token is valid or not on every backend services. So you don't have to go back to IDP every time. Now till now we have talked about authentication. So now we all know how we can do authentication in microservices. Now let's talk about authorization, right? So there's authorization comes with access policies. So authorization answers the question whether if an identified actor can access a resource and what level of access that identified user will get, right? And this authorization can be defined through an access policy. It can be a business rule, it can be a business policy as well. So if we see on the right hand side, I think the image is a little bit blurred. Let me see if I can zoom in. Let me go to the next page, maybe that will be better. Okay, I'm not going to explain this image because this is a little blurred, it will be hard to see. But anyway, I'm just going to explain in maybe 30 seconds. Like there's a report generator application on the top that tries to access some API. There are some other users, those are trying to access some APIs, right? And they want to access like someone's salary, and they should not be able to access someone else's salary if they are not the manager, right? So this is kind of like a HR system. And those should be kind of who can access which employee's salary. That can be performed through the authorization. Those policies can be defined through the authorization. Now, decomposing the access policies. Now, there are different ways we can decompose the access policies because access policy itself is a little bit of complicated. You can do all sorts of things. You can use like Spring Security, right? Using Spring Security, you can define those policies inside the code. But the recommended approach is to decouple your access policies outside your business feature code, right? So suppose what you are writing inside your Spring Boot application, that is not going to have any access policies. The access policy should be defined even the application being hit. So that's why we have different, integration points. So there is a policy execution points, or policy enforcement point, which is the policy execution. And then there is a PDP, policy decision point. And there's PRP, which is policy retrieval point. And PAP, policy administration point. And PIP is the policy information point, right? Now, when someone requests to the service, which is as a box here, right here, you see, right? Before the service, it hits the service, it kind of enforce the policy. Okay, I have some policy that needs to be checked if that user can access the service, right? And what policy enforcement point does? It talks to policy decision point. It talks to policy decision point saying, okay, you can decide based on the user value, or basically policy enforcement point going to submit that JOT value or JOT token to the policy decision point to see if the policy, based on the JOT token information, if the user can access the API or not, or access the application or not, right? Now, policy decision point talks to policy retrieval point to retrieve the policies, what policies being there. Then policy administration can edit or update or add new policies on the policy retrieval point. And there's a policy information point. So PDP takes the data from policy information point and takes the policy from the policy retrieval point, and it executes that policy. And then based on that execution, it returns back to the policy enforcement point saying if the access can be allowed or denied. So for authorization and access policies, in Kubernetes world, open policy agent is becoming the de facto. How many of you have used open policy agent? Anyone? Okay, I see only one hand here, right? Okay, so that's great. I mean, a lot of companies in US also, they are still not using OPA, but they are trying to go there, right? They have a proper defined backlog of implementing OPA for authorization, right? And OPA is a policy engine that unifies the policy enforcement across the stack. So OPA is little complex, but it also ensures to decouple the policies from your application code. So if you see here, there's an OPA server in the middle, and it talks to the service, and also it talks to the data and the policy. So OPA consists of policies, which are written in Rego code, and it also takes the data as input, and also it can reach out to other data source for getting external data. And based on the data and policies, OPA server executes those policies and see if the request can be allowed or not, right? Now, wow, there's no color here, but I have put color anyway. So, okay. So there is, so on the left-hand side, these are the source for the data, how we can get the data for OPA server. And on the right side, these are the source for the policies, how we can get policies for execution, right? And it's better for us to keep those data separated and the policy separated, right? And policy, the recommended approach is to get it from object storage or S3 bucket. Now, from the left, if you see here the data, right? The data can be streamed through Kafka topic and stored somewhere in the cache, right? It can be locally cached or it can be cached to other external data source as well. And there can be HTTP endpoint as well. So OPA has HTTP client which can reach out to HTTP endpoint and retrieve data for execution. Also, it can use a attached data volume, which can be also used as a data. So OPA policy execution with the data API. Running OPA as a sidecar container on the same pod will be the de facto way of how we can run OPA for authorization purpose, right? And we run a lot of other sidecars, like suppose service mesh, if we use Istio, we use Istio sidecar, right? So OPA will be a similar type of thing. Like if we integrate OPA, OPA will be running as a sidecar. Now we can reach out to OPA using the data API as well from our service, right? So each API, from each API, we manually, call data API of OPA, which is going to be running on the local host, basically, right, as a sidecar. And we can reach out to the data API, and then we can execute some policies. But this is not the recommended way of doing it in Kubernetes world. But you can do it in this way. So the recommended of doing it in Kubernetes is using the Istio, right? So if you use service mesh, even not with Istio as well, there are other service meshes supports this type of communication with OPA. So if we see here, so there is an identity provider on the top, right? So login service is talking to the identity provider IDP service. It gets the JOT token. It passes that JOT token to the Envoy sidecar. Envoy sidecar is for the Istio, right? So this Envoy sidecar talks to the OPA server. Now, so there are 3 hops that happens, right? Before the request reaches to the main service, which is the backend API container. That is the main service. But it goes to the Envoy sidecar. Envoy sidecar talks to the OPA sidecar, and it passes that JOT token to the OPA server. And what OPA server does? OPA server validates that JOT token first because it needs to authenticate, right? Don't forget to authenticate. So it uses the JWKS to authenticate the JOT token. And after it's being authenticated, then it uses the data and the policy. Then it executes that policy with that certain data. And then it validates that if whatever the policy is being said, right? If it's allowed or not, or if the policy can also return a JSON attribute as well. So for policy language, we use Rego. Rego is a very declarative language. It's a high-level declarative language, right? And Rego is not difficult to learn, but it's a little bit of unconventional language, right? So because each statement in Rego is either logical statement or kind of like you can have different type of like loops or anything like that, or functions or anything like that as well. But mostly it's logical statement. So these are the sample inputs when request comes from Istio. It's a big request. I think yeah, it's not being shown properly here. I think there's some problem with the projector, most probably. But yeah, so this is my presentation. I think I have covered most of those things like authorization and authentication. So if you guys have any questions, please ask. Any questions regarding OPA, how we can use OPA for Istio?
Thank you, Bhaiya. Let's say microservices তো হচ্ছে কি আপনার সার্ভিস রেজিস্ট্রি থাকে, রাইট? তো সার্ভিস রেজিস্ট্রিগুলোর সাথে হচ্ছে গিয়ে কি আপনার ওই অথরাইজেশন সফটওয়্যার যেগুলো আছে ওগুলো কি ইন্টিগ্রেটেড থাকে কিনা, এটা এটা জিজ্ঞেস করার ছিল ভাইয়া।
সার্ভিস রেজিস্ট্রি বলতে তুমি কি ডকার রেজিস্ট্রির কথা বলছো নাকি সার্ভিস রেজিস্ট্রি বলতে তুমি so এখন there are different ways. So microservice registry, you need microservice registry for service discovery purpose, right? So service discovery being done through kubeproxy here, like in Kubernetes world. So Kubernetes world, there is no service registry on microservices. So previously we used to use console like HashiCorp console as service registry for service discovery purpose, but now we don't use that in Kubernetes world. So there is no service registry where service gets registered, right? So there's Docker registry where the Docker containers gets pushed, and then like before deployment, it kind of gets it from the Docker container.
লেটস সে ফর এক্সাম্পল আমরা যদি ফেসবুকের কথা ধরি, হ্যাঁ, আমাদের একটা facebook.com একটা সার্ভিস অ্যান্ড messenger.com আর একটা সার্ভিস। তো আমি যখন হচ্ছে facebook.com থেকে মেসেঞ্জারটা ইউজ করছি, রাইট? তো একটা প্ল্যাটফর্ম আরেকটা প্ল্যাটফর্মের সাথে যে ইন্টারাকশনটা, তো ওখানে কিভাবে হচ্ছে ওরা অথরাইজেশনটা মেনটেন করছে। লেটস সে আমার মেসেঞ্জারটা হচ্ছে ফেসবুককে কল করছে, আবার ফেসবুক মেসেঞ্জারকে একটা ডেটা ইন্টারচেঞ্জ হচ্ছে, সেক্ষেত্রে কিভাবে অথরাইজেশনটা।
So, so first of all, এখানে কয়েকটা জিনিস যে these are all interconnected, right? Interconnected means first you need to do authentication, right? So when you are going to Messenger, you need to authenticate yourself that this is your Messenger account, right? So that is the authentication. Now the authorization piece comes here, that if you what resource you can use, or which message that you can see basically. That is the authorization piece, right? So that authorization, that is also can be done through authorization policy. So I think these decks will be shared with you guys. So there is a link in this deck at the very end. যেখানে there are examples of different type of authorization or authorization policies. So authorization policy গুলো এরকম যে with authentication যখন একটা jot token pass করা হয়, right? So jot token কে তুমি যখন decode করো, with decoding that jot token, you get a particular value of some user. You get user ID, username, maybe some other very basic informations of the user, right? So based on that basic information, you can reach out to another API. Like suppose you have a profile API, right? So you reach out to profile API to get more detailed information about that user. And then you decide, based on that data, you decide that what messages that user can see or view.